free fall may sound strange, but the word we normally use is acceleration due to gravity. So when we say acceleration due to gravity, another name for acceleration due to gravity is free fall or acceleration of free fall. When a body is falling vertically upward or downward, vertically upward, vertically downward, falling. If it's falling, then it means it's down. Then we say it is what? Under the influence of the Earth's gravity. The gravity here we are talking about is due to the Earth because we are on the planet Earth. So free fall is the motion of a body falling from a height under the influence of what? The Earth's gravitational force. So when the gravitational force of the Earth is pulling something which is placed at height above the Earth's surface, then we say it is free fall. Note the other names. It is also called acceleration of free fall, or you can call it acceleration due to gravity. Good. That's great. Let's continue. Now, let's look at the relationship between acceleration due to gravity and then universal gravitational constant. This is a very powerful relation you shouldn't forget. And it is given by this. The relation is given by this. This is the relation. And G stands for gravitational constant. Mass of the Earth is for capital M, then capital R is for radius of the Earth. So acceleration due to gravity is related to the mass of the Earth. It's related to the radius of the Earth. By that equation I've just given you. And when you have this, look at this carefully. When you have this, yes, and you multiply both sides by r squared, what do you get? You get G r squared is equal to Gm over r squared times what? R squared. The r squares cancel. And when they cancel, you'll be left with this equation. This equation is very, very important because sometimes when we are performing certain calculations, we can replace where we find Gm with Gr squared. So note this and never forget this equation. That is the relation. How do we prove this formula? How do we prove this formula? I'm going to prove it for you. So let's look at the proof. Proof of what? It's a very simple proof. When you have a body, the capital R and the capital M stand for the radius of the Earth and the mass of the Earth respectively. Let's say this is the Earth, and before we prove it, there are assumptions we make. We consider the Earth to be a perfect sphere, but practically the Earth is not a perfect sphere. And we also assume that the Earth is not rotating. If the Earth is not rotating, and this proof will work. And we also take into consideration that this body, some assumptions are already in America. No, we also assume that this body is negligible. Obviously, has negligible mass. So we assume that this body has negligible mass. Okay. If this is so, then what can we say here? Then this will be our R. Exactly. Although it has a negligible mass, but you call it M. And this Earth has also gotten mass, capital M. So when we are applying the Newton's law, the Newton's law of gravitation, then our F, okay, then our F, which we know to be J M1 M2 over R square, no, it will become what? It changes. This one changes. This one becomes what? It becomes F equals what? Let's relate this equation I have circled in blue with the diagram. Our J will not change. It will be capital M. Then the body's one will be small m over big R squared. Exactly. But don't let us forget that when the body is above the Earth's surface, when the body is above the Earth's surface, the body is pulled with, the body has weight, and it is gravity that contributes to the weight of the body. So here we will say that W is equal to what? F. Because weight is gravitational force exerted on the body. And we know that what is weight? It's mg. Is that not it? If weight is mg, when we continue, then what do we get? So we are still on proof. We are still on the proof. So when we put this, let me call this equation 1. So let's put W equals mg into equation 1. What do we get? Putting W, okay, putting W is equal to mg into equation 1. We are going to get what? We are going to get mg is equal to what? Jm m over r squared. Is that not it? Check it. When we put W equals mg into equation 1, are we going to get this? Will we get this? Okay. At this juncture, look at this. We have m here. We have m here. Small m and small m will cancel. And we will be left with what? So it's you proving it. Very simple. Very simple. We were able to prove it because of these assumptions that we make. Assumptions we make were: we consider the Earth to be a perfect sphere. We consider that the mass of both the Earth and the object are concentrated in the center. We also assume that the Earth does not rotate and the object is so compared. The size of the object is so compared, is so small compared to the size of the Earth. All right. So let's end here. Do you have any question? Do you have any question on what we have discussed? All right. Then we will end here. May God be with you all. God bless you. Bye bye.